Hello and welcome to this channel. I am teacher Stephen Omondio Cage. Today we are going to discuss the mechanism halogenation of alkanes, and I beg you work with me as we demystify the mechanism halogenation of alkanes. By the end of this presentation, you should be able to explain the steps involved in the mechanism halogenation of alkanes. The keynotes to know, there are things that you should know before you begin this process. It is a three-step process that we are going to discuss in steps and in details. The first one, the alkanes are unreactive compounds. Why do we say the alkanes are unreactive compounds? We know that they don't have the functional groups. Like we know the alkenes have the functional group, which is a double bond. We have also the alkynes, which have the reactive site, which is the triple bond. We have also the alkanols, where the hydroxyl are the functional groups where the reaction takes place, and also the alkanoic, the carboxyl, where the reaction is taking place. So generally the alkanes are unreactive. Another key is in order to get alkanes to react, they must be paired with the reactive radicals. So for them to react, they must be paired with other reactive radicals, such as the chlorine radicals, the bromine radicals, and then they don't react. The iodine are unreacting, so they cannot react with the iodine. That one also you should be able to know. Then another key term is halogenation of alkanes is a three-phase radical substitution reaction. Substitution reaction is just a replacement. To substitute is to replace. We can replace hydrogen with chlorine. We can replace hydrogen with bromine, just like that, and like that. The first phase here is initiation. We must initiate the reaction by forming the radicals from the paired radicals, maybe from chlorine atom. When a chlorine atom, not atom, but molecule, when a chlorine molecule, when we subject it to heat, that heat will now break the bond, forming the free radicals. So those free radicals are the ones that are responsible for the reaction in this case. The step two, then we have the step two, which is propagation. So in propagation is where the reactions and the formation of them, the hydrogen chloride maybe, bromomethane, chloromethane, such are being formed. In propagation, we ensure that the reaction is reacted. It reacts until there is no reaction that can take place anymore. Then we have termination. Now in the termination is now the end of the reaction, where the radicals react with radicals to form a compound. The radicals react with the radicals to form the reaction. So in termination, we only deal with the radical reactions. Only the two radicals combine to form a compound, which is a non-radical. Then the next, now let's take, for example, let's take, for example, this general reaction. This is a reaction between propane and bromine. So when the propane reacts with the bromine in the presence of the UV light or the heat, it will be the one hydrogen. Sorry, let me pick So one hydrogen from here will be substituted with one bromide atom here to form bromopropane. So this bromopropane is formed because one hydrogen, sorry, one here should be 7. Sorry for that. There is 7 there, not 6, but 7. Sorry for that. You can make that correction. So one hydrogen here is replaced by one bromide atom here to form the bromopropane. So this and the hydrogen that has been replaced by bromide combined with another bromide atom here because there were 2. So one combined with that hydrogen now to come and form what? The hydrogen bromide. So one hydrogen which has been replaced here by the bromine is combines with one hydrogen bromide atom hapa to form now what is called the hydrogen bromide. So we can explain this equation using the phases that we said are involved in mechanism of hydrogenation of alkanes. So the first one we said initiation. So initiation, we said that the radicals, the non-radicals are converted to the radicals for them to, because we said that alkanes can only react with the radicals, and the radicals are the free ions. They are free ions. They don't have the bond which holds them tightly. So they are loosely held so that they can take part in a chemical reaction. For example, in this our case, we have the bromine, and there are 2 atoms. You can check here as we proceed. So we are going to describe the mechanism in we are going to describe the mechanism in the halogenation process, mechanism hydrogenation of alkanes more so for the halogenation of the bromine. So let's take for instance this bromine. We have we had 2 bromine atoms here. So we link them with the bond that holds them together. So this bond, you realize that for the in the presence of the UV light or the heat, the radicals, the non-radical compound. This one is a non-radical compound. So it breaks up where the one electrons come there, another one goes here to form, or when it goes here will form this X. So this is the ion. Also this one, or electron, this one also free electron that can now make this one to react. So one electron takes one bromine takes 1 electron, another one also take that electron. So those are now free electrons. So this is now what we call the radical. So the radicals are more reactive. So you can see, so this non-radical breaks up all the bonds. We call them the cleavage bond that holds them together are now broken now to form what we call the free radical bromide atoms. So the radicals are most reactive. So that is why they can now react with the alkanes to form the respective compounds. So the radicals gives us, under the presence of sunlight, they give us what we call the the non-radical gives us what we call the radicals, and the radicals are more reactive. So you can check that. So the movement of electrons are showed by a half arrow, hook or hook arrows that you can see that way. So we have said the bond that holds these the atoms together. They are called the cleavage bond. They are called homolytic cleavage bond. So this, when the homolytic cleavage bonds are broken with the sunlight, the heat from the sunlight, they form the radicals which are able to react with the alkanes, in which our case is the propane. So from initiation, we now go to the propagation. In the propagation, we now form the products. Let's come back first. In the propagation, we'll be able to form these two products. You ensure that you form these two products in propagation, and that is why we have three reactions in propagation. One is for the formation of the bromide ion, the bromide hydrogen bromide. Another one will form the bromopropane. You should be able to know that. So propagation. So in propagation, the one bromide radical reacts with the propane here. And now you realize that here there will be transfer or sharing, the transfer of electrons, I mean. So you realize this free radical ion or electron will come this way and combine with the one electron from this to form now what we call the hydrogen bromide, which was one of the products, which is the one of the products when the bromine reacts with the propane. Then also this will have also another free ion which will be taken to this part, free electron, which is now this X here, which is that X. So this free radical, the radical reacts with this to form another radical of different kind. So this bromine, this bromide from the initial radical here, let me show you, go back, that you can be able to know. So here, one bromide here now react with this one to form the hydrogen bromide and the radical of the propane, the propyl radical. It's called the propyl radical. So we were here. You can see this one react with that to form hydrogen bromide, and also there is an free electron which will now give us the radical known as propyl radical. So that propyl radical. Then we said we form, this is the product, which was, we had explained it in the previous display. Then we have also this one. Now, whatever we have formed here, this propyl radical, the propyl radical now reacts with the radical that was formed with the non-radical, that is the bromine to bromine atom. Because now we are, what I mean, let me go back. For the reaction to take place, we said that alkanes reacts with the radicals. So those radicals, we gotten them when we expose the bromine, for example, in this case, the bromine to sunlight to give us the bromide radicals, which we gotten. And one of the bromide radical react with the what? With this propane to give us the hydrogen bromide and the propyl radical. So to be that alkanes must react with a radical. Here you can see it is reacting with this radical. So then whatever we have gotten here now reacts with the bromide or the bromine, I mean, the bromine atom. This one. So this one is an radical and this one is a radical. For those reactions to take place, there must be a radical and an radical. So you can see this one reacts with this one, where this one, that free electron will combine with one free electron from this side to form what we call the bromo propane, this one now. And also this one, there another free electron which will go there, will be taken with this one to form the bromine radical. You can see that it's just a self-explanatory. So in this propagation, what you have to know, we are now forming the products when the bromine reacts with what? With the propane in the presence of sunlight. We know that we get the hydrogen bromide and propane. And that is what I want you to know with those two products that I've explained how they come about. Let us see the last step, which is termination. Now, the end of the reaction here. We realize that in the termination, let me go back a bit. In termination now, these radicals that we have here, that one, this one, and also this one, they will react and form a compound which is a non-radical. So these four radicals will now react. For example, this one will react with this to give us the bromide atom, the bromine atom, which is a gaseous diatomic. Also, this one also will react with this one to give us what we call the hexane, that you should be able to know that. Then also this one will react with this one to give us propane. Let's see those reactions, how they are taking place. So you can see this one. The bromide radical reacts with the bromide radical to give us the bromine atom, which is a non-radical. So to mean the radical react with the radical to give us non-radical. We have another one here. The propyl radical react with the propyl radical to give us the hexane, that you should be able to know that. Then we have that is a radical react with a radical to give us that. Then we have last one, which is the bromide atom react with the propyl radical to give us the bromide, that is the propane, which is a non-radical. So those are, in termination, we have three reactions where all those radicals reacts to give us a non-radicals that you should be able to know. You can see this one, they are they are two. This one plus this one will give us two. This one and that, you combine them together and that will give you a non-radical. I think it is just simple like that. We'll be able to demystify further and further and further. For now, digest that as you know how to prepare for your examination and how to answer them. So what I want you to know, you must know that alkanes are non-reactive, but alkanes can react with the radicals. The radicals in this case are from the halogens, the halogen radicals, where can be chlorine radicals, can be bromine radicals, and fluorine radicals. So that because iodine does not react with this. So then the first step here, we have 3 steps. We have initiation. In initiation, we are making the halogens radicals. That is chlorine to chlorine or bromine to bromine. We make them to have the radicals. Then one of the radicals formed there will now combine with with what we call in this our case it was propane. So that propane now reacts with one radical from the bromine to form the propane and what we call the propyl radical. You should be able to know that. Then again, we have the nili that we have formed there, what the propyl radical. The propyl radical that we have formed will now react again with the bromine diatoms. That is bromine to bromine, where in that case will now form the hydrogen bromide plus the bromine radical. I want to get that clear. So here, there we'll have those 4 radicals now will react in termination to form the non-radicals of the respective compounds. Otherwise, thank you. Next time we'll be now discussing the alkynes. Alkynes, their preparation as from tomorrow. So you can subscribe, hit the notification bell so that you can be notified once we upload a new video. Have a nice time.